So we're going to start looking now at something called the properties of logarithms. There are three of them. We start with log base b of two things being multiplied. And if you ever have that, you can separate it into log base b of the first thing plus log base b of the second thing. The second property says that if you are dividing inside the logarithm, you can separate it in the log of the first thing minus the log of the second thing. And the third property says if you have what's inside the logarithm to an exponent, you can drag that exponent out front so that m no longer has an exponent, the exponent's out front. So let's look at some examples here. So in this problem, we're told that log base 5 of 3 is about 0.683, and log base 5 of 7 is about 1.209. So if I want to find this without a calculator, because we can't use one yet, I have 3 over 7, and according to that property, then I'm going to subtract. So I will rewrite this as log base 5 of the first thing, 3, minus, because this is a divide problem, I'll do minus log base 5 of the second thing, 7, which means now I can replace log base 5 of 3 with 0.683 minus, I can replace log base 5 of 7 with 1.209, and then we can just use a calculator to do the subtraction. So 0.683 minus 1.209, and we get a negative 0.526. Now in this next one, I have log base 5 of 21. Now 21 is not 3 or 7, but I can rewrite 21 as 3 times 7. And so then I can separate that to log base 5 of 3, and the rule says that I could separate that with a plus, log base 5 of 7. So we get log base 5 of 3 is 0.683, plus log base 5 of 7 is 1.209. So we add those together, and I get 1.892. And the very last one here, we've got log base 5 of 49. 49 can be written as 7 squared, and according to that last rule, I can take that 2 and put it out front. So I've got 2 log base 5 of 7. Now according to the problem here, log base 5 of 7 is 1.209, so I'm going to take that times 2, and I get 2.418. Okay, now a lot of times people look at this and wonder how in the world does that work. So I'm going to do a little proof here. First off, let's get a couple things set here. Let's say that log base b of m equals u. Okay, so I'm just making this up. I'm saying I'm going to set that equal to something, and I'll just call that something u, and then log base b of n equals v. So I haven't really done anything yet. I'm just giving those things a value, just like in class when we used to say that this equaled x, that I could put it in exponential. Alright, that means if I rewrote these in exponential form, I would have b to the u equals m, and b to the v equals n. So now I'm going to take log base b of m times n, and I'm going to replace the m with b to the u. So I have log base b of b to the u. And I'm going to replace the n with b to the v. And then we're just going to use our exponent rules. If I have log base b and I have two bases being multiplied, I'll add the exponents. And then Tetris effect says that this is going to equal u plus v. And if I go back up here, u equals log base b of m. So I'm going to replace u with log base b of m. Plus, and then v equals log base b of n. So I'm going to replace that with log base b of n. And so what I've done is I started out with log base b of m times n, and I ended up with log base b of m plus log base b of n. Now I'm not going to ask you to be able to do that on your own. It's just I wanted you to see why that's true and how that kind of works. So the main thing that you're going to do is you're going to do something called expand. So I want to see this in your notes when I check your notes. Expand means that you get one thing inside the logarithm and you have no exponents. So you want one thing inside the logarithm and no exponents. So if you look at this problem, I've got 2 and x inside the logarithm, and I have an exponent of 6. So I only want to get one thing. So the first thing you do is you separate stuff out. This 2 and the x are being multiplied. So I'm going to use that first rule to say that this is log base 5 of 2 plus log base 5 of x to the 6th. So that was the first rule, where I have these two things being multiplied. I separate it out into a plus. Now if I look at log base 5 of 2, there's nothing going on. There's no exponent. There's just a 2 there. But if I look at log base 5 of x to the 6th, I've got an exponent. So I need to take care of that using that rule where that exponent can go down in front. So now this will be log base 5 of 2 plus 6 log base 5 of x. And then we're done. Again, there's only a 2 here, there's only an x here, there's no exponents. So we are done with that problem. Now in this next one, we've got a bit more going on. We have a y on top, but then it's been divided by 3x squared. So we can separate that out. This is a divide problem. So this will be equal to log base 7 of y minus log base 7 of 3x squared. Okay, now if I look at this again, I've got just a y here, so that one's done. But then on this one, I have a 3 and an x squared, so that's not done. The other thing I need to be careful about, this is minus all of this. So as I separate it out, I need to make sure that minus goes to all of it. So I'm going to put a parenthesis around it. And then I separate it. These are being multiplied, so I'll separate it into a plus. And then the only thing I have left is I have to take that 2 out in front so that I don't have that exponent, but I can also distribute the minus sign to both of them. So then I get log base 7 of y minus log base 7 of 3 minus 2 log base 7 of x. Now one of the things I want to point out, sorry about the bell by the way, one of the things I want to point out is, a lot of times you can save yourself a little bit of this confusion by looking up here. If your 3 and the x are both on the bottom, they're both going to have a minus in front of the logarithm. See, the minus is saying it's like a negative exponent. It's got to move it to the bottom. Okay, so the minus is going to move that 3 to the bottom. 3 was on the bottom, so there's a minus in front. X squared was on the bottom, so there is a minus in front. Okay, so if there's a plus, it means it was on the top. If there's a minus, it means it was on the bottom. So let's look at this one. And of course, they do get a little bit more complicated, but if we look at this one, we have a couple things going on the top. We have 7x cubed going on the top and just a y on the bottom. So my big picture is that I have this division, so I'm going to separate that out. So I get log base 2 of 7x cubed minus log base 2 of y. And then I need to focus in on the 7x cubed. They're being multiplied, so I'm going to separate that out with a plus. So log base 2 of 7 plus log base 2 of x cubed minus log base 2 of y. And I'm almost done. Remember, you just want one thing inside your logarithm, and I do have that, except the one problem is this exponent that I need to move out in front. So I will rewrite this as log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y.